Hi, this is Jason Baker, and welcome back to the lecture. I wanted to spend a little bit of time talking about some of the other AWS services and resources that you might use in combination with a Lambda function to create a full-fledged serverless application. And let there be no mistake, you can create an entire application platform in AWS using nothing but serverless components, meaning that you don't need to use EC2 instances or container services or even traditional relational databases. You can use all serverless based components to create a website, an application that supports millions of customers. So let's take a look at some of the services that you might use in combination with a Lambda function. The first one is AWS API Gateway. And the API Gateway solves a really big problem, which is how do you trigger a Lambda function from the web, from your web browser? So if you want to create a dynamic web application and you want to use Lambda functions as the application tier layer of your platform, how do you invoke those Lambda functions from your web browser? Well, you do that using an API gateway. So essentially, the API gateway takes on the role of a front-end web server in a traditional application stack. So you might use traditionally something like Apache or Nginx as your web server, and Nginx is allowing you to trigger your Ruby code or Python or PHP code or whatever. In the case of Lambda functions, you can't run a web server in a Lambda function. So you have to have some front end web server that's proxying requests from customer web browsers and invoking Lambda functions. And that's what the API gateway allows you to do. The API gateway allows you to build a RESTful API. And the API gateway is deployed as a web proxy within the CloudFront service. So it actually creates a CloudFront distribution, which is either going to be an edge optimized solution or a regional CloudFront distribution. When you're working with the API gateway, you are basically setting up two key components. You are setting up different resources within the gateway. You can think of these as being the nouns within a RESTful API. For example, you might have a resource called /API/user or /API/company, or just simply slash. So like the root resource is going to be sort of the default web page for your application. So you set up the resources, and along with resources, you set up methods. And these are like the verbs in a RESTful API, such as HTTP GET or HTTP POST. And you combine both the resources and the methods to create your API. For example, if I wanted to get the information on a particular user within the platform, I might send a GET request to the, myapi.com/API/user question mark with a query string of ID equals 123. And that my Lambda function then would be designed to get some information about that user and return it. What the API gateway is going to do is it's going to, when it receives a request like this, it's going to send an event to a Lambda function. It will invoke a Lambda function and pass this information, like the query string and the request headers, along to the Lambda function. And you can design the Lambda function then to do whatever you need it to do. to handle that particular request. These API resources and methods, you can set them up manually, or of course you want to define them in something like a CloudFormation template. You can also use the Swagger language to define APIs, and Swagger is a really common syntax for describing APIs. Another service that you will commonly use in combination with Lambda functions is DynamoDB. And we talked about DynamoDB earlier this semester. It's a NoSQL database that AWS has created. It can act as both a key value store and as a document database. And it can store things like dictionaries and JSON objects. It's what I call sort of a web addressable database. And the great thing about DynamoDB is it's completely managed by AWS. We can sort of, configure and tune our database table instances, but we don't have to worry about, managing the database service and maintaining it and so on. It's all taken care of taken care of for us by AWS. There's two key components to think about when working with DynamoDB tables. The first is the actual table. When you create, when you're working with the DynamoDB service, you create a table in DynamoDB, and the table is what actually stores your data. It's a way to group and partition sets of data. Within a table, then, you will store items, and items are groups of data attributes that you put into the table. You can kind of think of an item as being something like a row in a traditional relational table. But of course, DynamoDB is not a traditional relational database at all. It's a NoSQL database. And each item can be different. So the items will share a key, but the item contains, sets of attributes, and each item can have a different set of attributes, which, you can think of it like, imagine like a traditional relational database, but each row in the database can have whatever set of columns it wants. And so DynamoDB and these sort of NoSQL document databases are very flexible in terms of the types of data they can store. When you set up the table in DynamoDB, you have to specify a unique primary key. And you're going to use the primary key in every single query that you make to the database. The primary key is used by DynamoDB to reference your item and to find items within the database table. There are two types of primary keys that you can set up. One is what we call the partition or hash key, and this is a single attribute that you define in your table that's going to be used as the primary key. This could be something like a user ID or company ID or order ID. It's just a single value, and the single attribute is going to store some unique data. And this attribute is going to be used to partition your data within DynamoDB. The second type of primary key that you can set up is called a composite key, and it consists of not only a partition key, but also a sort key. So in this case, you actually have two different attributes which combined together create a unique primary key. and you'll use the partition key to determine where to store the data within DynamoDB, and then the sort key determines how the data is actually going to be ordered within the database. When you're performing queries on DynamoDB, then you need to provide the primary key. That's what allows DynamoDB to access and retrieve your data and to find it very, very quickly. Here's an example where we're sending a query to DynamoDB. We're specifying the table name, which is music, and we want to do a query where the artist is going to equal A and the song title is going to equal the variable T. The variable A is no one you know, and the variable T is equal to the value call me today. If you were to write this sort of query in relational SQL syntax, it would look something like this select statement, where we say select star from the music table, where the artist equals no one you know, and the song title equals call me today. So this DynamoDB query is roughly equivalent to this SQL syntax. When DynamoDB processes that query, then it will respond back with a JSON object. And in this case, it's responding with 2 items. So it shows you that the count is 2. And there are 2 items in a list. And so there are 2 different items which match this particular query. When you're working with DynamoDB, then you're sending these query objects and you're receiving back these query responses in JSON format. One other thing that's really interesting about DynamoDB is you can set up DynamoDB event streams, and you can connect these event streams as an event source to Lambda functions. This is a way in which DynamoDB can trigger Lambda functions. You can imagine a situation where you're updating a DynamoDB table. The updates that take place in the table can trigger AWS Lambda functions. So every single time you update an item in a table, DynamoDB can trigger a Lambda function and give it the information from that update. The Lambda function can then do something like update another table, or it could send an SNS notification. It could do whatever it wants to do. This sort of functionality is sort of a way to emulate stored procedures in a serverless environment. So you can use stored procedures in relational databases to programmatically do things when table rows are updated that can trigger a stored procedure. You could do roughly the same thing with DynamoDB event streams and Lambda functions. The third resource and the final resource that I wanted to quickly cover is Kinesis, the AWS Kinesis. The AWS Kinesis service allows you to create massively scaled message queues. If you recall, early in the semester, we talked about different cloud architectural patterns, distributed architecture patterns, and message buses were one of those patterns. It allows us to decouple different services within our application. And we can use Kinesis as a message queue. And there are all kinds of different scenarios where you might want to use Kinesis. So for example, maybe you have an application, let's say it's a big data application, and it needs to ingest massive amounts of data. Maybe this data is coming from thousands of different servers that are pushing log files into the Kinesis stream. Or maybe you have thousands of different devices out there that are collecting data, and these devices are pushing data into a Kinesis stream. The data that is pushed into the Kinesis stream is going to be stored in shards. And a shard is a way to partition the data within a stream. And it also is a way to increase or decrease the amount of bandwidth that's available within a Kinesis stream. By default, when you create a Kinesis stream, it has one shard, which allows for a certain amount of incoming bandwidth and outgoing bandwidth. So you can make a certain number of incoming requests and outgoing requests from a shard. If you need to support more requests, either more producers, message producers, or more message consumers, then you add additional shards to the Kinesis stream. And you can just keep adding more and more shards. And you can think of that as making your stream bigger and bigger and bigger, and it can support more messages. The messages that are pushed into the Kinesis stream are stored within the stream for 24 hours by default. So they just sit there in the stream and they accumulate for up to 24 hours. You then have message consumers, which are consuming the messages in the stream. And message consumers could be other application services. They could be Lambda functions. And these message consumers are reading the messages that come into the Kinesis stream. You can have multiple consumers that are reading messages from the stream. And the consumers are, you can think of them as sort of iterating over all of the messages in the stream. And so you could have different consumers that are sort of at different locations within the stream. So some consumers maybe started earlier and they've processed more messages, and some consumers that are newer, maybe they haven't quite processed all the messages in the stream yet. Here's just a quick a pictorial diagram showing you sort of an overall picture of how this Kinesis stream works. You have on the left-hand side, you have message producers, things like mobile clients or other internet services. You could have systems in your corporate data center, and they're pushing messages into your Kinesis stream. What is a message? Well, a message could be something like just a JSON object. It could be a blob of data that is being pushed into the message stream. When that message is pushed into the stream, it ends up on a shard. If you have more than one shard, then your messages, you want to try to sort of distribute your incoming messages across the different shards within your Kinesis stream. And that allows you to optimize the bandwidth and performance of the stream. On the right-hand side, then you have different consumers, and these could be things like, they could be application services running on EC2 instances, or containers running in AWS Fargate, or Lambda functions. And these consumers are reading messages off the Kinesis stream, and then they might be processing that message and updating other services like S3 buckets or an Amazon DynamoDB table, or they could even be pushing the message into yet another Kinesis stream. And here's a diagram kind of showing you a little bit more detail what a stream might look like. On the right-hand side, you have the message producers, and they're pushing messages into the stream. And a stream consists of a number of different shards as represented by these different horizontal layers within the stream. And then you have consumers. The consumers are reading messages within in the stream. In this case, there are 3 different message consumers, and they're all reading from different shards, and they're all reading from different locations within the stream. So maybe one consumer started before another consumer started, and so it's a little bit ahead of the other consumers in the stream. The point here is just to show that you can have multiple message consumers reading from the same stream concurrently, and they're all going to be reading from different points in the stream depending upon when they started reading messages from that stream. Well, how do we put all these concepts together? We can use these different serverless resources to build a full-fledged web application. And here's how sort of a simple application might work. First of all, you create front-end client code in your favorite JavaScript framework. Maybe it's like Angular JS or React or whatever your favorite JavaScript framework is. You've created sort of a single page application and you store that front end code in an S3 bucket. When a customer goes to your website, they're going to make a request to the API gateway. And the API gateway might respond back with a link to your front end code that's hosted in an S3 bucket. So your customer and their web browser will load up the single page front end JavaScript application. And then they will continue making requests to the API gateway. They'll hit different resources, different API endpoints that are provided by the API gateway. Those different endpoints may trigger Lambda functions. So you'll hit a Lambda function. Maybe the customer is trying to request the current weather conditions for a particular region of the country. That request is sent to a Lambda function. That Lambda function then reads data from a DynamoDB table, responds back to the API gateway, and the API gateway then proxies that and responds back to the customer, where then the data and the information is presented within the single page application running within the customer's web browser. You can use all of these different resources in combination to build a full-fledged end-to-end application that's running in a completely serverless manner, running on services that you don't need to manage or maintain. As a application developer, then you are solely focused on building out your application code and creating things like CloudFormation templates to orchestrate the building of all these serverless resources.